Let's give you another chance or another crack at how to do these problems. Another example that I have here provides the unit measurement for one leg and the hypotenuse. And to find the six trigonometric functions, I need all three sides. So again, I can call on my friend Pythagoras and solve for that remaining side. So in this case, I'm going to have leg 1 squared, which is a 1, plus a b squared, equals hypotenuse squared, which is a 9. Solving that, b squared equals 8. Take the square root of both sides. Gives me a 2 root 2 as its positive length. So what I have here then is that the positive length here is a 2 root 2. So now I have all three sides. And once I have all three sides, it's just a matter of getting the correct ratio for which particular function I'm looking at. So my sine of theta, again, if here's theta, sine is the opposite over hypotenuse. So that's 1/3. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. Here, I'll put little equals there for you. The cosecant is 3 over 1. Its secant is 3 over 2 root 2. And our cotangent is 2 root 2 over 1, or just 2 root 2. And there you have the six trigonometric functions for this particular triangle. Now you'll notice, and you might kind of remember from our previous studies, that typically we don't like leaving a radical in the denominator. And so therefore we need to rationalize the denominator. So if, just for example, we'll do the tangent of theta. So if tangent of theta turned out to be 1 over 2 root 2, I need to do something very clever to eliminate that radical in the denominator. And one of the things I need to do, or the thing I need to do, is look for a very clever version of 1 to use. And the clever version of 1 I'm going to use is a root 2 over root 2. And again, if you multiply anything by 1, it doesn't change the original quantity. And so here's what it is. This is essentially a 1. And choosing that very clever version of 1, multiplying the bottom, 2 times root 2 times 2 is 2 times a 2, which gives me a 4. And 1 over root 2 gives me a 2. And so therefore the tangent of 1 over 2 root 2 is the same thing as root 2 over 4. And therefore I rationalized the denominator. And you can do likewise with the other one that needs to be rationalized, the secant as well. Same process.